In this lecture, you will learn about how to graph the most general form of sine and cosine functions. Let me describe the pattern of functions. It'll be y equals a times sine of k times x minus b plus c, or y equals a times cosine of k times x minus b plus c. Let's analyze each component. Let's look at y equals a times k times x minus b plus c. As we know, a is related to amplitude. Amplitude was absolute value of a, and this k, which is multiplied directly to x, determine the period. Period was 2 pi divided by absolute value of k. The difference between the previous patterns and this pattern is b is subtracted and c is added. When the number b is subtracted directly from x, that indicates the horizontal shift. When the number is added to the entire function, that is vertical shift. In this format, if b is positive, then that means shift right. If the number b is negative, then that means shift left. If c is positive, then that is shifting up, and if c is negative, then that means shifting down. What you have to be very careful here is if you look at the sign in front of b and sign in front of c, then you can see that sign in front of b is negative and the sign in front of c is positive. So whenever you think about the horizontal shift, that is counterintuitive, and the vertical shift, that is according to your intuition. Other important thing you have to remember is this number b is directly subtracted from x. So if this inside is like k x minus b, then you have to rewrite that as k open parenthesis x minus b over k. And then you will realize that in this case, the horizontal shift is b over k, that is not b. Let's do some example. Find the amplitude period and phase shift of the function and then graph the function. The first problem is y equals 4 minus 2 times sine of x. When we graph the function, we figured out amplitude, period, and key points. In this section, we are thinking about the phase shift together. So we have to think about one more factor. Let's fix this into the standard form. Y equals minus 2 times sine of x plus 4. After that, we will figure out the meaning of each component. There is a vertical stretch that determines the amplitude. Amplitude is always a positive number, so we just drop this sign. This minus means the vertical reflection. And this one is period. This one determines the period. There is no number multiplied to x. Therefore, the period is the same as original period, which is 2 pi. Here, the number 4 is multiplied to this function. So there is a vertical shift. Up 4 units. When you draw the graph, usually we follow the order of operation. Step 1, we will graph the multiplication part, but we will follow the general pattern of the sine function. So we forget this minus sign for a while and graph 2 times sine of x, and then we will consider this reflection, and then we will shift up. When we go from here to here, there will be reflection along x-axis. When we go from here to here, 4 is added, so shift up 4 units. Let's graph the step 1. Step 1, we will graph y equals 2 times sine of x. As we discussed, amplitude was 2 and period was 2 pi. So key points will stay the same as the original sine function. So this is pi over 2, this is 3 pi over 2. Let's graph it. The amplitude is 2, so maximum will be 2 and minimum will be minus 2. Let's say that is 2 and this is minus 2. Then we can draw the dotted horizontal line. And then we are graphing y equals 2 times sine of x. Nothing has changed. Sine passes the origin and then go up and down as a wave pattern. Then join those points nicely to complete the graph. The second step was reflection along x-axis. When you reflect along x-axis, zeros will stay the same, but 2 will become minus 2, and minus 2 will become plus 2. This blue graph is y equals minus 2 times sine of x. The last step is about vertical shift. So we have to think about the maximum and minimum of this graph, and then we will just shift up. Maximum in this graph is 2, and minimum in this graph is minus 2. What you have to keep in mind is this is y equals 0. If we shift up 4 unit, then it will go up 4 unit. So y equals 4 will play the role like x-axis in this graph. Let's graph y equals minus 2 times sine of x plus 4. So maximum will be 2 plus 4, which is 6. And minimum will become minus 2 plus 4, which is 2. Y equals 0 shifts up to y equals 4. So y equals 0 was the x-axis. The entire graph will be located above x-axis. Let's put the dotted line at the minimum and maximum and shift it x-axis, which is y equals 4. What we are doing is we are transferring this graph, this blue graph. It starts at the origin, which is this time 4, and then we have to go down and then make a wave. This is the final answer for this question. Before we work out the next question, let me discuss the even and odd function property of sine and cosine. When you learned in college algebra, you already learned even and odd function. Let me remind you about the definition. Function y equals f of x is an even function if f of x equals f of minus x. That means when you switch the value of x value, the function value stays the same. That means the function is symmetric with respect to y-axis. A function y equals f of x is an odd function. If f of minus x equals minus f of x. That means if you switch the sign of the input, then function value switches its sign. If it was positive, then it'll be negative. That means the function is symmetric with respect to the origin. What I want to say is a sine function is an odd function and cosine function is an even function. At this stage, you can just look at the graph and decide whether those are even or odd function. But to discuss that more precisely, I will use the unit circle. Sine function y equals sine of theta is an odd function. That is, sine of minus theta is the same as minus sine of theta. Here is the reason. We have a unit circle here, and this is theta. This is minus theta, and this is A and B. On the unit circle, what I said was x coordinate is cosine and y coordinate is sine. If we reflect that point, then that will be associated with the negative angle. If you just think about the coordinate, then A, it'll become A and minus B. Because of the unit circle property, what we know is that is cosine of minus theta and sine of minus theta, because that is associated with the angle minus theta. But if you just look at the coordinate itself, then B was identified as sine of theta, and minus B will be minus sine of theta. This coordinate A, x coordinate, didn't change. So when we compare the value, that can be rewritten as cosine of theta and minus sine of theta. We are talking about the same point. That means the x coordinate must be the same and y coordinate must be the same. From there, we can say that sine of minus theta equals minus sine of theta, and cosine of minus theta is the same as cosine of theta. If you look at the definition of even and odd function, that indicates sine is an odd function and cosine is an even function. So a cosine function is an even function. If you look at the graph of sine and cosine, this is the graph of sine which passes the origin. If this is theta and this is minus theta, if you think about the distance between the origin and that point, the distance between the origin and this point, then they are in same distance. So this is symmetric with respect to WRT means with respect to the origin. That is the odd function property. If you look at the graph of cosine function, then that looks like this. If you flip along y-axis, then the graph on the right side will be entirely overlapped with the graph on the left side. Therefore, cosine function is symmetric with respect to the y-axis. That is the geometric property of even function. Let's apply what we learned to draw the next function. Y equals cosine of pi over 4 minus x. In the standard form, x appears first. So let's convert the form into the standard form. We just switch it the order of two terms, then we get minus x plus pi over 4. We pull out minus, then minus open parenthesis x minus pi over 4. So that when we multiply these two by distribution, it should be plus. So we can rewrite that as y equals cosine of minus x minus pi over 4. Then we can rewrite that as cosine of x minus pi over 4. We can forget this minus. That is because cosine is an even function. When we switch the sign of the input, in this case here, this number, to positive, the cosine value will stay the same. Now let's analyze what's going on. Y equals cosine of x minus pi over 4. Instead of thinking this function, we will just think about y equals cosine of x minus pi over 4 because those will be the same. Nothing is multiplied to cosine, so that is amplitude equals 1. Nothing is multiplied to x, so period will stay the same, that is 2 pi. And there is minus in front of pi over 4, so we can interpret that as a horizontal shift. Right pi over 4. Nothing has changed other than just the horizontal shift. What we will do will be we will graph cosine function. And then we will graph y equals cosine of x minus pi over 4 by shifting pi over 4 to the right. Let's graph y equals cosine of x. We already know how to graph cosine function. One is the largest value and minus 1 is the smallest value. The benchmark happens every pi over 2. Cosine function start at the maximum. This is something we already know. Second step is graphing y equals cosine of x minus pi over 4. What we know is we have to shift right pi over 4. That means we have to shift the original key points pi over 4 to the right. We will just mark at the key point pi over 2 and pi, 3 pi over 2 and 2 pi. Then we will add pi over 4. For each key point. The first key point will become pi over 4. Then the second key point is 2 pi over 4 plus pi over 4, which is 3 pi over 4. all we have to think about is the difference between these two numbers. Then that is 2 pi over 4. Of course, that is pi over 2, but you don't have to, we think about the denominator pi over 4, so we will go with adding 2 pi over 4. So this one will be 3 will become 5 pi over 4, and that becomes 7 pi over 4, then 9 pi over 4. Let's graph it. The maximum is 1, and the minimum is -1. This is pi over 4 to 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4, and so on. This time it is shifted to the right pi over 4 amount, so the starting point is not y-axis, it'll be right above pi over 4. So we start from here, and then we just draw the apparent wave. When we go to the left, I subtracted 2 pi over 4, so we got minus pi over 4. This is the final answer. Y equals cosine of pi minus 4 minus x. We already discussed why these two are the same, because that is cosine function property, which is even function. The next one is y equals 3 times sine of 2 over 3x minus pi over 6. When we graph this, we have to figure out amplitude, period, and phase shift. Amplitude is 3, and period is determined by this one, 2 pi divided by 2 over 3. Again, this is numerator, this is denominator, so we can multiply numerator times reciprocal of the denominator, which is 3 over 2. So these two will cancel each other, and it becomes 3 pi. Let's discuss the phase shift. Phase shift is 2/3. We have to figure out the number directly subtracted from x. That means we have to take out 2 over 3. 2 over 3 open parenthesis x minus, we have pi over 6 here, but when we multiply these two numbers, we multiply 2/3 as a redundant, so we have to eliminate that by multiplying by the reciprocal. So that is 2/3 times x minus 2 times 3, so that is pi over 4. The 2 will cancel each other, and 2 times 2 will make 4. From here, we can conclude that phase shift is 4 horizontal, shift right pi over 4 unit. We will take 2 steps. As I said, generally we follow the order of operation. The multiplication will be taken care of first. 3 times sine of 2/3 x and then we will shift it to the right, pi over 4 unit. Step 1. We will graph y equals 3 times sine of 2/3 x. We already know the amplitude. Amplitude was 3 and period was 3 pi. All we have to do more is figuring out the key points. That is 0 to 3 pi, and we have to divide the interval into 4 equal intervals. So 3 pi over 4, and then the distance will be the same. The next one will be 6 pi over 4, which is 3 pi over 2. And then if you add 3, then that will become 9 pi over 4. And then it becomes 12 pi over 4, which is 3 pi. Let's graph this function. Maximum is 3 and minimum is minus 3. Let's just go through the benchmarks. 3 pi over 4, and then 3 pi over 2, and 9 pi over 4, 3 pi. This is minus 3 pi over 4. This is a sine function, so it passes through the origin, and then just make the natural wave, you know. That is the graph of y equals sine of pi of 2/3 x. To finish the problem, we have to shift to the right 4 unit, pi over 4 unit. Step 2 is graph y equals 3 times sine of 2/3 x minus pi over 6. I said that can be rewritten as 3 times sine of 2/3 open parenthesis x minus pi over 4. The key points will be shifted to the right. Let's mark at the original point. 3 pi over 4. We will add pi over 4, so let's just copy over 4. Then 6 pi over 4. Then 9 pi over 4. 12 pi over 4. Then we have to add pi over 4 for each one. So the first one is pi over 4. Then pi over 4 will make pi. And this is 4 pi over 4. The difference is 3 pi over 4. So we will keep adding 4 to the numerator. Then the next one will be, actually it is easier to just add pi over 4. Then 7 pi over 4 plus pi over 4. Then that is 10 pi over 4, which is 5 pi over 2. Then when we add pi over 4, that will become 13 pi over 4. Let's use all the information to shift the graph. Mark at the maximum and at the minimum. This is 3 and this is minus 3. Let's be just rough. This is pi over 4 and then pi. Then 7 pi over 4 and 5 pi over 2, then 13 pi over 4, then 16 pi over 4, which is 4 pi. If you subtract 3 pi over 4 here, then it'll be minus pi 2 pi over 4, which is minus pi over 2, but we will leave it like that. Minus 5 pi over 4, and so on. What we want to show is a graph is shifted to the right pi over 4 amount. That was the sine graph. We start at 0. That is the final graph of y equals 3 times sine of 2/3 x minus pi over 6. The next graph will contain all the transformation. Y equals 4 plus 3 times sine of 2x plus 1. If we change that to the standard form, then that looks like y equals 3 times sine of 2x plus 1 plus 4. So the amplitude, which is determined by the number multiplied to sine, will be 3, and period, which is determined by this, will be 2 pi over 2, which is pi. And we want to think about the phase shift. The phase shift is 2x plus 1. So whenever we think about the phase shift, we just take out the number in front of x. So 2 times x plus the reciprocal of the number we took out. From here, other way to go, express the same thing is x minus 1 over 2. That implies that is shift left 1 over 2 unit. Be careful, this is plus, but that says counterintuitive. That goes to the left. There is a vertical shift because 4 is added. A vertical shift up for unit. This time we are thinking about the vertical part, which is not counterintuitive. Plus means going up. What we want to graph first is the horizontal and vertical compression or stretch. Graph y equals 3 times sine of 2x, and then we will think about the horizontal shift. Graph y equals 3 times sine of 2x plus 1. And then the third step will be, we will graph y equals 3 times sine of 2x plus 1 plus 4. So we consider the vertical shift also. Let's do this first step. In step 1, we graph y equals 3 times sine of 2x. We already determined the amplitude. The amplitude was 3. And the period was pi. Apparent key points should be 0, pi over 4, pi, and 3 pi over 4. Let's combine the information. This is pi over 2. The maximum is 3, minimum is -3, and benchmark happens every pi over 4, pi over 4, pi over 2, 3 pi over 4, pi, and so on. This one is minus pi over 4. This is minus pi over 2. This is minus 3 pi over 4. This is about the sine function. That is the graph of y equals 3 times sine of 2x. The next thing we want to do is we want to do the horizontal shift to the right pi, just a 1 over 2. Not shift to the right, shift to the left 1 over 2 unit. We already discussed that. You may ask whether you can just add 4 first and do horizontal shift next. The answer is yes. But if you do vertical shift first, then the graph will be separated from x-axis, and so it becomes a little bit inconvenient. So that's the reason we are doing horizontal shift first. Step 2, graph y equals 3 times sine of 2x plus 1. As we said, we have to shift left pi over 2 unit, meaning we have to subtract 1/2 for each benchmark. Zero, and this is pi. This is pi over 2. This is pi over 4. This is 3 pi over 4. And we shift left 1/2. We will now simplify further by using common denominator. Minus 1 over 2 will give minus 1 over 2 here. Let's be just a rough. Then the maximum and minimum will stay the same because there is no vertical shift. This time it is shifted to the left, so what was in the origin will be shifted to the left, pi over 2, minus 1 over 2 amount. So the first benchmark will be minus pi over 2, minus 1 over 2. Then pi over 4 minus 1 over 2. Then pi over 2 minus 1 over 2. And 3 pi over 4 minus 1 over 2. Then pi minus 1 over 2. And so on. This is the sine function, so it starts from here, and then it'll follow the obvious pattern. That is the graph of y equals 3 times sine of 2x plus 1. Step 3, that is graphing. Graph y equals 4 plus 3 times sine of 2x plus 1. This is vertical shift up for unit. The original maximum was 3, and the original minimum was -3. So we have to add 4 to each component, making that the maximum 7 and minimum 1. As you can imagine, the entire graph will stay above the x-axis with minimum 1 and maximum 7. Y-axis will be, the x-axis will be shifted to y equals 4. So it looks like this. So this is y equals 4 plus 3 times sine of 2x plus 1. This time we will do opposite reasoning. The graph will be given, and then by looking at the graph, you have to figure out amplitude, period, and horizontal shift, and then you will combine those information to figure out the equation of the graph. This is the graph. Obviously, this looks like cosine functions graph, and this is one cycle, but there is a vertical stretch and a horizontal compression. Amplitude for this function is 7, and period is pi. The graph starts at the maximum point, and it resembles cosine function graph. So there is no horizontal shift and no vertical shift. It starts at the maximum, not at the minimum. And it is not flipped along y-axis, so there is no reflection. We already identified the pattern of the graph as cosine function's graph. So y equals a times cosine of k times x, because all we can see is vertical stretch and horizontal compression. There is no reflection. That means a vertical stretch, which determine the amplitude, will become a. So a is 7, and we know period is pi. That came from 2 pi divided by k. There is no horizontal reflection. That means k is positive, so you don't have to put absolute value here. That equals pi. We multiply by k on both sides, then we have these two will cancel each other, and 2 pi equals pi times k. And then we divided it by pi on both sides, and these two will cancel each other, and also these two will cancel each other. So k becomes 2. We combine that information to conclude the problem. A equals 7, and cosine of k is 2 times x. Let's do different pattern of the graph, which will be involved to the sine function. This is the given graph. The first thing you have to look at will be whether that start at maximum or minimum, or start at the origin. In this case, the graph start at the origin, meaning you will identify that with sine function. There is no vertical shift or horizontal shift because that start at the origin. So y equals a times sine of k times x. From here, the amplitude is 5 because maximum is 5 and minimum is -5. There is no reflection. That means a equals 5, not -5. We know that the period is 4 pi. This is 4 pi. That came from 2 pi divided by k. We have to solve for k. So 4 pi k equals 2 pi. We divide by 4 pi. on both sides, then k will be 1 over 2. We just combine those two information. Then the final answer will be y equals 5 times sine of 1 over 2 x.